Morning, guys. Sorry I'm not there today. What I decided to do instead of pushing back the lesson or you just copying notes from a substitute is give you some video notes on what you guys are supposed to be doing today. So the substitute that you're with should have given you this note taker. If you guys could please fold it, and then you're going to put it into your notebook on the next page, following what we just did last class with the multiplying polynomials. While I'm doing this, I'll just explain. As you're going through this video, feel free to stop it, pause it, rewind it, whatever it is that you need to do to help yourself. But as you are going through the video, I expect that you'll be taking the notes just like you would be doing if I were in class giving you the notes that way. Okay. So today we're talking about perfect square trinomials and difference of squares. Essentially what these are just special cases of polynomials. So what we'll do is we'll just title this polynomial special cases. And then make sure that you are putting whatever your page number is for 7-3. So we've moved on to lesson 7-3, looking at those polynomial special cases. You'll see a couple of examples of these. They're actually pretty easy, and you can use previous strategies to solve them, but they're really helpful to know what these special cases are because it makes solving them a lot easier. So without any more waiting, we're going to start with perfect square trinomials. Okay, and what these perfect square trinomials are, if you look on the inside of your notebook, you're going to see two different examples of this. You'll see a plus b squared, which is essentially a plus b times a plus b. In this situation, you do not distribute the exponent like you would do if you were multiplying. You have to multiply this by itself twice. So don't accidentally make that mistake. And then the other perfect square trinomial is a minus b squared. Okay. What I'm going to do is I'm going to show you what it would look like if I were to use the FOIL method. You could use the table method. It doesn't really matter. Both methods work. But I'm going to show you with the FOIL method what this would turn into, and then I'll show you the rule. Okay. So for the first one, a plus b squared, or a plus b times a plus b. The FOIL method says you're going to multiply the first times the first, which is a times a, or a squared. The O means the outsides. You're going to multiply together. A, B, so, or A times B, which is AB. Then we are going to do the inside, that's the I of the FOIL, B times A, which can also be written as AB. BA and AB are exactly the same thing. And then, last but not least, we end with multiplying the last values. So that's B times B, or B squared. If I simplify that, it becomes a squared plus 2ab, those are like terms, they have the same variable group, plus b squared. Okay, so the rule is whenever I see something where it's a plus b, or two numbers added together, and that whole quantity is squared, we would use this rule. Now, you're not really going to see a problem where it's two variables. What you'll probably see is something like this, where I have a variable added to another number, or something like that. So let's go ahead and take a second and look at what that looks like here. Okay. Again, x plus 4 squared would be the same as x plus 4 times x plus 4. I'll show you using the FOIL method, and then I'll show you how I can skip the whole FOIL method and just use my rule to make it a little easier on ourselves. So again, FOIL would be first times first, which is x squared. O is outside, x times 4, which is 4x. Inside, x times 4, or 4 times x, and then last, 4 times 4 is 16. Okay, so simplify that, it's x squared plus 8x, plus 16. So that's using the FOIL method. But if I use what I know about the rule here, we can translate it in a different way. So I'm just going to do that on this side over here. So first we did FOIL, now we have our rule. So essentially, if I have two values, a binomial where they're adding together, what I'm going to do is I'm going to start with the first term, that a term, just like I have here, and I'm going to square it because that's a squared. In this case, a is x, so the first term is x squared. The second term, 2ab, means I'm going to do 2 times the first term times the second term, because the first term is a, the second term is b. So what it looks like over here is 2 times x times 4. And I'll just write that like this, and I'll simplify it in a second. The last part of this trinomial is b squared. That's the second term in the problem squared. So in this case, our second term is 4 squared. All right, I'm going to go ahead and simplify this. X squared is just x squared. 2 times x times 4 is the same as 2 times 4 times x, so 8x. And last but not least, 4 squared is 16. That right there is the trinomial that you would get. Notice it's exactly the same as when we use the FOIL method. The only thing is we used our rule, so we didn't have to go through multiplying everything by itself. So this one's a special case because it's just the quantity multiplied by itself. Now the second one that we're looking at is, well, in this case, instead of adding, we're subtracting. When I'm subtracting, I'll show you the FOIL method. I do my first times my first, which is a squared. My outsides, a times negative b. Don't forget that that minus is a negative b, so that's negative ab. Then I've got my insides, which is negative b times a, and my outsides, negative b times negative b, which is positive b squared. When I multiply them together, it's a squared minus 2ab plus b squared. So the only difference here is that instead of this being a plus, it's a minus, okay? So those are the only two things that you need to keep in mind. Notice it's exactly the same as the rule. So let's go ahead and look at this example. I'm not going to FOIL it out like we did before because I feel like you guys should know how to do that. We're just going to jump right into the rule. Okay, so if I know that a minus b squared should equal a squared minus 2ab plus b squared, we can just figure out what is a, what is b, multiply the things together, and then there's our trinomial. So in this case, a being the first term is x, so I'm going to do x squared minus 2 times a times b. So 2 times the first term times the second term. So 2 times x times 12. Last but not least, I'm going to add b squared. In this case, our b is 12 squared. And then we could just simplify. X squared minus 2 times 12 is 24x plus 12 squared is 144. Okay. Once you get used to this, you can really even skip this step because you should be able to multiply this in your head. I just want to show it on the notes how to do it because our notes are a reference point and we want to put as much information in it as possible. Okay. If you need to stop or rewind or pause at any point, please make sure you're doing that, okay? Because I'm about to move into this second special case. The second special case is the difference of squares. Okay, we just started with the perfect squares trinomial, and that was a plus b squared or a minus b squared, and we had those special rules. This is a little different. The only difference with this one is instead of it being squared, you're multiplying a plus b times a minus b. So they're the same a and b terms, only one is added and the other is subtracted. Okay, looking at the FOIL method, the solution would be a times a, or a squared, a times negative b, which is minus ab, b times a, and those are both positive, so this is plus ab, and the last is b times negative b, so it would be minus b squared. Okay, if I were to simplify that, the a, b terms cancel out, one's negative, one's positive, and then you end up with a minus b squared, a squared minus b squared, excuse me, which you can see here as the rule. I notice I wrote vice versa is the same. That just means a minus b times a plus b would use the exact same rule. Okay, so what does that look like for our example? Our example, x minus 8 times x plus 8. Notice the a and b terms are the same for both. The only difference is one is minus and one is plus. What we'll do is we'll just go straight into using that rule. We're going to do a squared minus b squared. So since a is x, we'll do x squared minus b is 8 squared. And then I can simplify this as x squared minus 64. And ta-da, that's it. So this one's actually a really easy one. All of them are pretty simple once you know the rules. You don't have to do the FOIL. Now, if you still are wanting to check, of course you can FOIL it out or you can use the table method. It doesn't mean you can't do that. These just make it a little bit easier to solve these questions quickly. So, with that said, we are going to be done with our notes. Today, you need to make sure that you finish these notes and then you also finish that worksheet. Tonight's homework is going to be 8.2 Envision Online, 8-2. So please make sure you get that one done. I will be collecting the work tomorrow. I will be back tomorrow, so if you have any questions on this, I'd be happy to answer them. But that's all you have to know about polynomial special cases. Use them to your advantage. I'll see you on Wednesday. Bye, guys.